may I get people together at this point? Looks like everybody gives me a number, and it seems to be a nice number. So the answer seems to be 140. I've seen it at every table. So I wonder why. Why is it 140? Does anyone want to comment and tell us why? Anyone? Anyone? Dan wants to come, but I think that Kelly? Is your name Kelly? Okay. Kelly told me that they had 3 ways to get that number. So can you share one of the ways, the way that you feel the best is the best?
Okay.
All right.
In our group, we started very differently. For 2 people, they started with the 7x7 grid, but I went back to the 1x1. So I just started with 1 square, and I counted how many squares of different types. So I'll just put this up here. I don't know if everybody can see. But in my 1x1, I just had 1 square total. Then I went up to the next size, which was a 2x2. And in the 2x2, I had 1 2x2 square. And then I had 4 1x1 squares within there. So I started to just kind of keep track of it in terms of the size of the square within the smaller squares than what we started at. Got it?
Do you have any questions? Okay, thank you. Now, when Kelly started talking, I didn't pay much attention to what she was saying. I heard 1x1 and 2x2, and so I started writing a table. And so this is the size of the squares in this grid. And then the next column is what is the number of the squares of this size, number of squares of this size. So some people did it that way. How many did it this way? Lots of people did it this way, right? So how many 1x1s? And of course 7x7 is easy. Okay, now how many 2x2s? How many 3x3s? 4x4s, 5x5s, 6x6, and then the total is just the sum, and that's 140, right? Okay, now, of course, if you look at these numbers here, there is something pretty interesting. We recognize the number as being perfect squares. And then, of course, the next question is why? Why do we have these perfect squares? And I think that Casey has a great way to explain why we have perfect squares. Like, Casey, can you explain why, for example, there are 36 of 2x2s?
So I started just like by shifting the square. So like this is 1, 2, 1, 2, 3, 4. I'm losing track. Yep. 4, 5, 6. And then from there I could shift down.
She actually made this square. See, she just cut it out of blue paper. She made the square. She actually was moving, yeah. She actually was moving this square. Made the square and just moved it around the grid. That was a great idea. I thought first that she anticipated the question and actually flew from Chicago with that piece in her pocket. Now, one thing that might be even more revealing, so to speak, is if you take that little square, that blue square, but also we earmark it. Just put a dot in one corner. Doesn't matter which corner. In fact, we could have even put it in the middle of it. Doesn't matter. Let's suppose that we put it at this corner. This green dot is on that corner of our blue square that we are moving. Now, when we move it once to the right, the green dot would be right here, right? Everyone with me?
Yes.
And then we move it once again to the right. The green dot is there. Once again, and we cannot move it further, right? Then we move it all the way back and start moving it down. When we move it one down, the green corner now is right there. And then we start moving it again across, and we have all these positions of the green mark. Then we move it all the way back here, one down, and then start moving it across. One more down, and then move it across. One more down, and move it across. One more down, and move it across, and we cannot move it further down. We would get out of the grid, right? And now this array of green dots is clearly a square array. And we can just see it. And we can do the same thing with all of these numbers, of course.